Hi everyone, welcome back to Stationeers. Right, I am going to, I've basically been having a play with printers. On my Venus episode, two episodes ago, I set up a way for the printers to automatically turn off the stackers and to also count how many of an item they were printing before, obviously, stopping. It was the first time I'd used load device and save device, so it wasn't perfect and it had a few flaws in the code. So what I've done is I've spent some time improving on this, plus I've done some additional coding, and I just thought I would share it with you, see what you think, and then kind of go from there really. So to start with, we'll cover the silos shortly, what they're for. So for anyone who watched the Venus episode, this code will look familiar. Basically, we aren't using any pins. So, as you can see, all the pins are set to no device. Ignore this one for now. But everything is using device IDs. So, we define the auto leave, the stacker, the reset button, which is new. And we'll go through that shortly. Including a couple of LEDs as well, just for information more than anything. And the long and short of it is that we can set any number on the stacker. So let's say I want 10, and let's say I want 10 mugs. We're going to print ourselves 10 mugs. Excuse me. This console up here is telling you what the stacker is set to, and this one is giving you the export count for the printer. And what will happen is once this hits 10, the printer should stop printing. Easy peasy. So there you go, it reset the count to 0, it's now waiting for the next job, and we have 10 cups, mugs, whatever you want to call them. Perfect. Now, there was a suggestion on the comments that said, obviously, the problem is your count is going to count up whenever you expel the ingots. So, I've changed the code, so if I expel the ingots now, you will see it's sticking out the ingots, and what you'll see is that the ingots are in higher stacks than the 10 that we originally set. That is because my code now checks whether the printer is open, and if it is, it sets the stacker to 500 because it assumes that you're going to be exporting your ingots, and you don't want tons and tons of ingots. If I close the printer, you can kind of see there, because it's closed, the code is now continuing, and it knows that the stacker setting is on 500. The reset button, this is where this comes into play. I don't want to be sat here turning this, get it back down to 50. If I hit my button, it sets it to 50 for me. Very simple code. This specific code does no more than that. It just works. And this is kind of the code in its most basic form. So it's obviously, we're loading from the reset button first because it's always checking the reset button. If the button has been pressed, it will save to the stacker a setting of 50. It then checks if the printer is open. If the printer is open, so I'm going to get confused here, 1 second. So if we have a look at the auto leave, because I can't remember what I wrote. So the open one is open. So here, where we're checking, is it equal to 0? So if it's 0, it's closed. If it's closed, we're happy to go and do some further checks. So we go down to the further checks here. We load that, we check that the printer is on, and we save the on status to the stacker. We then check that the on, basically, is it on? If it's off, so which will be 0, it jumps back to start and continues the loop again. If this was a 1, it means the printer is on. So we're then going to load from the stacker the setting, and then we're going to save that setting, and that is just the LED. So that is what is controlling that one there. So that's that. And then we're going to load the export count from the printer, and we're also saving that to an LED. So at the point here, we have the setting from the stacker, and we have the export count from the printer. We're going to check that R1, which is the export count, is not equal to 0. Okay, because if it's 0, it's assumed it's either just started or it's not doing anything and it's not long been reset. So we're checking 1, is there a number there? If there's a number there, we know it's working on something. We're then going to check that R1 is greater than R0. R1 being the export count and the setting being R0. If the export count is greater than R0, so the export count is greater than the stacker setting, R3 becomes a 1. We're then going to combine that check with the check that the export count is not 0. If both of those are a 1, we're going to clear the memory. We're going to reset the printer. If it wasn't, it's assumed that at this point it is that this I wrote this bloody code and can't remember. So we're checking here that R0 equals 0. Remember, R0 is this count up here. So if it does equal 0, it's going to jump to start. So that means that the export count is not greater than or equal to the setting. So at this point, it's either 0 or it's not finished printing the amount that we want. At which point it goes to start. If that is true, so either it's got to be not 0 and the export count is greater than the setting, then we're going to activate. And what that does is just stops the printer. That is basically simulating me pressing this button. That's it. And that's basically that code. Now, obviously, it's only one printer, but we'll get onto that shortly. What I've been trying to do, and what I've successfully done, is I want this printer to be able to request ingots. Now, I know you can do it in a way that it requests the ingots required for the build job. Me personally, I would rather my printers just had so much of an ingot in there. Personal preference, it's just how I've done it. Do it however you want. So that is on this code. Now you can see up here, I currently have a console displaying what the printer is requesting. Now you can see in there, it's got the 50 copper. So in a second, I'll put some more in. And that is because in my code, let me show you what I've done. Actually, we'll go through the code shortly. But you can see here, obviously, it's cycling through each of the ingots. So over here, look, we can see we've got 83. So I think I've got it set to 99. So if there's less than if there is less than 99 of an ingot in the printer, it's going to request some. So in a second, that will change. And it will move on to the next ingot. And that's just, obviously, this was empty because we removed all these ingots. So I've gone for the silo approach. I know you could do a vending machine. I prefer the silos, again, personal preference, because I could store more into these. The idea with one of these is you can hold 600 stacks. And if you think that each stack can hold 500 ingots, that is a lot of ingots. Whereas the vending machine can only hold 100 stacks. So I'm not a massive fan of using that. Obviously, it would be a lot more slimline as a build if you use the vending machine. I just like the silos. It adds a bit more of an industrial feeling, and I could just stockpile tons. And what I could do is have my stacks of 500, and then on the output of the silo, we could have a stacker, which is just splitting it down into 50s. Coming out of each silo, we have these digital valve chutes. I have these set to 1. So as soon as a ingot, and I can just show you. So as soon as an ingot travels through, it immediately closes. I've done the chute because they respond quicker than the silos do, just opening and closing. That's the only reason there. Again, we could replace this with a stacker if we wanted to, but I went with chutes. Again, no real reason, just what I did. But yeah, we have a chute coming out of each silo, all set to exactly the same, all set to 1. And then that is just what's controlling our ingots coming through. This chute is just for me to dump in what I want to do, because the idea is, if you didn't have steel, for example, in a silo, I could just chunk steel into it, and that would be absolutely fine. Over here, So this is the ingot that it's currently checking. And alongside that, you can see how many we have in the printer. So we've got 100 silicon, 130 gold, we've got 149 copper, and 133 iron. Okay, and that's how quick it's checking. There's only one yield in the code, so it's pretty fast. We are using the stack. So this is just for information. This is telling me whereabouts in the stack it's working from. And this will display a number if it's requesting an ingot. This is being connected to from this console here. So that's how it's getting it. The code is right into that, and then that is connected to that. For the code, here we are. So a little bit longer than the first one, but it works fine. I'm only doing 4 ingots, but there's no reason you couldn't add more to this. I've just done 4 because I was testing 4. You could, if you wanted to, have the alloys, the advanced alloys, but I've never got to a point where I've always had loads of them, so I don't see the point in automating them. But yeah, so you have to do it in this order. So you've got to go the reagent, the chute, the ingot. The reagent, the chute, the ingot, and just do it in that order. When you create the stack, it lands on the end, and that is where you start from. Down here, so again, with this code, if you have a look, we are only using a pin for the auto leave. Now, we have to use a pin on this code because you cannot, I can't figure out a way to load reagents from a printer without it being on a pin. You can't batch load reagents. You can't load reagent from a specific device. You can load the total reagents, but it will not give you a split. You can't do it, so you've got to have the printer on a pin. But you know what? One pin for this code, I am not bothered. This works. So there's our stack point LED, the one that I showed you. We just put the ID in there. The hash console, that's just the hash console with the display. That's this one here. The printer total LED, so that's the LED that's giving us the number, so that is this one. The chute left, the chute right. I'm just defining both of these because it occurred to me that if I'm setting this up, I might decide to use the other chutes, which are on this side, and they have different hash numbers. So I'm just batching both of those, or defining both of those, so then I've got them in my code. The reagent hash LED is that guy there. So then we alias the printer, and note that I've called it printer, not auto leave. I'll go through that later why. I've then just defined a couple of registers just so I can use them throughout. This one is holding the stack pointer so that we can always refer back to it later in the code. And here you can see we want at least 99 of an ingot in the printer. I could set this if I wanted to, so let's go for 150. If we export that code, it should now start requesting gold. And there you go, so it's going to move on to the next one. And as you can see, it's just working. And it's also color coding the LED because why the hell not? So, pretty straightforward to be fair. Load whether the printer is open. If the printer is equal to 1, so if it's open, just go back. We do not want to be running this code while that printer is open. There is no point. And then down here, we're going to pop. So what pop does, and maybe I might explain this slightly wrong, is it takes the number wherever it currently is in the stack and then moves a line. So we store this within the register of our choosing. So we're storing it within R0. And then the stack pointer gets moved down. For anyone who hasn't used the stack, when you push items to the stack, it's kind of like it's a table of data in the background, like a single column of data. And your stack pointer, so your position in that stack, is wherever you last pushed an item. So by popping, we were here. We're taking that number into a register, and then we're moving our pointer here. It is last in, first out. That's how the stack works. So we pop that into R0, and that is the hash. Okay, so that is the hash of the gold ingot. So that's what we've currently stored. We're then going to store that into another register, just so we've got it for safekeeping. Okay, that way we can't accidentally override it. We're then going to pop again into R0. So this is why we moved it here, because we want to reuse that register. So this one, we were here. So we're going to grab this number and we're going to move up a line. So at this point, we now have the gold chute in R0. We're then going to move the chute device and we're going to make that R0. So the value that we grabbed from the stack has been moved into a different register. Done. In theory, just thinking about this now, I could have popped that directly into the chute device. There's no reason for me to have this extra line of code. That has just dawned on me now, but never mind, we're fine. Next, we're going to pop it again. And this, you can see here, look, we're bloody popping into current reagent. So I don't know why I didn't do that before, never mind. But what that's doing is we are here, so we are taking the reagent, we're storing that into the register, and then we're pushing the stack pointer to here ready. And that is this. And then we're going to save to the SP LED, the stack pointer, where we currently are. So that's why you never see a 12 on there, because we only save it once we've jumped up 3. So we can see 9 is where we're going to be next time. Again, just for information, really. Then we're going to save to this the DB, which is the housing, the ingot hash, which we stored earlier. So as you can see on here, we're kind of flicking through. And that console is connected to this. So that is how it's getting its image of an ingot. It's that. So then we go down to check start. We are loading the reagent total. Well, sorry, we are loading reagent into reagent total, which is another register, from the printer, the contents, and then the current reagent, which is what we stored from the stack earlier. We are then saving to the LED the setting of the reagent total. So that is just that. Is how much we've got in there. Down here, branch greater than. So is the reagent total greater than the amount that we want? If it is, we're going to skip. So if I want 100, but I have 101, we're going to just jump to skip, which is down here. But for now, let's say we've got less than 100. So we're going to move down here. We're going to save to the color. We're going to save the color to the LED, makes it red. It's just the number 4 for red. If you're not sure about the colors, look in the Stationpedia. Here, we're going to save to the LED, the ingot hash. Now, an important note, which took me a second, was when you are reading a reagent from the printer, right, you are not reading the ingot. You are reading the reagent. This, I stumbled on this for a few minutes. Basically, when you search for iron, you've got your iron ore, you've got your iron ingot, and then you've got your iron reagent, okay? This is how it exists inside the printer. If you want a console to display what is in that printer, you have to use the reagent. It doesn't matter that it comes back out as an ingot. When it exists inside a printer, it is a reagent, not an ingot. So this is displaying the ingot hash. This is displaying the reagent hash. Okay? And it just happens that it puts the iron or ingot image on there. It just works. But just bear that in mind. If you can't get this working and you can't figure out why, check that you're using the correct hash. So that's that. And then here, once we've got to this point, we're obviously requesting something. So we are then going to trigger the open on the chute device. And what that does is it basically just presses that button. That is the open. It closes by itself because we have this set to 1. As soon as one item passes through, it resets. So we don't have to worry about a close. We are just triggering the open. And then we sleep for 5 seconds. Now this number here is determined by how long it takes for the ingot to pass through. I timed it and figured 5 seconds is enough. Obviously, if this was closer, I might be able to get away with like 2 or 3 seconds. But that is why if I do this, it sits on that for a little while because it's counting to 5. But yeah, that's that. And then up here, it just jumps back up to here because what it wants to do is double check that the ingot it requested has taken it above the value that we want. If it hasn't, it just rinses and repeats. It requests the ingot. If we already had what we wanted, if we were absolutely fine and like, oh, we don't need any more ingots, it's going to jump to skip. And all we're doing to here is we're saving to the Regent hash LED 0. We're saving it as green. And then down here, we are checking whereabouts we are in the stack. Because if, whoopsie daisy, let's say, so we've ran through the first time, we are now here. If we're here, we want to just carry on. So you're going to pop that value, move the stack pointer there, then we'll pop that value, move up, pop that value, da 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 da. When you get to here, the stack point here is 0. So even though I have 12 lines, we're actually on 0 here. This check down here is saying if we're equal to 0, then we need to obviously reset the stack. So here, if it's greater than, so if the stack pointer is greater than 0, so it's not 0, then just skip the next line. So jump down 2 lines, jump to start. If we are at 0, we are going to move the stack pointer to the start of the stack, which is what we gathered up here right when we initialized the code. So it always has 11 or 12 or whatever number it is. I can't remember. It'll be number 11, maybe. It just stores that and it starts the loop again. That is how that works. And it works bloody well. Now you can see here, it's still requesting silicon. And that is probably because we look at my silicon. That's my gold. That's my silicon. I have no silicon in here. So I'll just chuck this in. Obviously, there we go, requesting it. And then it should be happy. And it should move on. There we go. No longer requesting ingot. Done. And that is my printer. So, thanks for watching. Oh, wait a second. I can hear you asking me a question. I hear you asking me, this is all well and good, but your code only works on a single printer. How is that any good for anyone? Well, that is a very good question, so I guess I'll carry on just for you. Ah, sounds so sad. So, it takes quite a lot of work because the idea that there are tons and tons of codes on the workshop, on the Steam workshop. If you want something like this, it'll be on there. Chances are Mick, or otherwise known as Cows Are Evil, has written a script for pretty much everything. I personally don't want to take other people's scripts. I'm happy to look at them from inspiration, but I'm trying to learn the code myself. And just copying and pasting a person's code is not me learning. I prefer to build my stuff from scratch. So everything you see here is built from scratch. I haven't copied anything from anywhere. I just took a lot longer than I care to admit figuring it out. So, obviously, my thinking was I don't want to go over 2 housings. Okay, I've got one housing that works for the auto crafting, and that is where it's obviously doing the numbers, turning this off. Yeah. I have another housing for the ingot requesting. I want to keep it like this. I don't want to be putting multiple housings all over the place. I think some people will probably have a separate housing for each printer, and then that printer requests from the system what it needs. Whereas my system is the code requests the ingot, not the printer. So in my head, it should be easy. I think this is doable. You don't need multiple. And once more, can I do it on 2 housings by only using the pins available to me? Okay. The answer, yes. Piece of piss. I can. Now, obviously, it's not here, so let's go and visit my next area. So, as you see over here, I have 3 printers. I have my autolathe, my electronics printer, my pipe bender. You don't have to use 3 printers. I could very easily do it as 2, or you could maybe push to 4, but I ran into a slight problem and I'll explain that to you. Gone for the same style of setup, otherwise this time I've color coded them. Very nice. We still have the chutes, but I've also put stackers in. So I put in like stacks of 500 and the stackers are set to 50. If I press a button, obviously it provides the ingot. That ingot is going to run all the way through. It gets kicked out here because none of my printers are requesting that ingot. None of them want it, none of them care about it, so they're just like, yeah, don't want that. You know what? Neither do I. So, a little bit more involved, as you can see. We've got all these chutes. I've tried to make it as compact as possible. There's no reason for it to be this tight. This is just what I've done. Each printer has one of those. I can't remember what that's called. It is called I think it's just a digital valve. No, it's not. Digital flip-flop. It's a flip-flop. And they are all set to a ratio of 0 to 1. 0 to 1, 0 to 1. By default, these will pass straight through. So I've got that chute running all the way through to here. This will only do this when it's being requested by the printer. Okay? Otherwise, it just stays in that mode. Let me turn the codes on. So, you can see everything's on, everything's working. If I try and turn one of these flip-flops, it should, in theory, turn back. But it probably... Oh, there we go. It did. Okay, boom. So, what's the difference here? Well, the first bit of the code is exactly the same. Apart from, I copied it multiple times. I've tried to include as many notes as possible, mainly for my own sanity. But if anyone requests this code, more than happy to share it if you think it's something that you're interested in. All you have to do with this code is basically chuck your chip in and just change these IDs to whatever you have. So we've got the printer, the stacker, the reset button, and then a couple of LEDs. And we have that for every printer. If you're not sure how to get these codes, you want to grab your tablet with a configuration card. And if I just do this, you want to just point at the device. And the ID you want is this, including the dollar symbol. Okay, so this one is $5ED3. In my code, you'll see $5ED3. So you just want to go to all your devices and just set that up. If I'm sounding condescending, I apologize, but this is me. Once we've defined it, the code runs exactly as I told you before. Apart from the part of the old code where it would jump to start, it just jumps to the next piece of the code. So on the old code, it would jump to start. Here it would jump to start. I've just changed it and put jumps to the next code. And then for the electronic, same thing. It will jump to the pipe bender down here. And then these obviously names here are just because I've done like P3 stands for printer 3 further checks. But that's it. The code is exactly the same. Nothing new there. Just works perfectly fine. I could have used the stack if I wanted to, and I could have also used the pins for the printers, but I don't want to do any of those things. I was just having a play, but that's how that works. Look, it works exactly the same. I can eject my ingots. If I turn off the printer, I can actually close the printers, and I could put my ingots back in like so. If I turn that on, there's still some ingot in there, so we'll grab that, put it back in. You see that my other chip is requesting the ingot, even though I've just put some in. Doesn't matter, it's fine, and it's happy. This is part 1 of my code. This will work without the ingot requesting. So if I want to on my playthroughs, I'll just use this to start with until I've got a setup similar to this. This code was a lot more difficult. So what I've had to do is I have had to do 3 printers, each on their own pin. And over here, I've got the consoles on the other pins. Now, you will see that as I hover over that, it's flashing. The reason it's flashing is because you can pick and choose which device you want to use on your code. I didn't know I could do this. It took a few goes at like moving registers, aliasing, defining. But at the bottom of my code down here, you can re-alias a pin into the same named alias. So normally at the top you would alias your printer to D0, alias your pipe bender to D1. But if I did that, I would have to copy my code 3 times for it to go through each printer. What I'm actually doing is when I get to the bottom, I'm checking where I am. So I'm checking which printer have I just checked. If I've just checked printer 1, so if my flip-flop is printer 1 flip-flop, then jump to activate to printer, which is down here, and I re-alias to the name printer the D1 pin. So I am cycling through these pins to run my code. You don't have to alias them just once, which I thought was a pretty decent game changer, but maybe I'm just overly excited. But that's a good tip to know. You can re-alias. So if you want to run your same code on multiple pins, just do that. The code isn't much different, apart from it's got a little bit more complexity in it. You'll also notice down here, I am very close to the size limit. I actually hit the size limit because I was just chucking comments in everywhere, and then it started going red and it started moaning at me, and I was like, yeah, okay, I need to remove some comments. So if I wanted to add more ingots, I would have to delete some comments off this because there isn't enough lines for me to be able to add additional coding into this. I've hit the max. But the code up here is pretty much the same. We've still got my LEDs, my consoles, obviously. Nothing here is different. It's just laid out slightly, well, different. That is all the same. Down here, though, I have the flip-flops, which I pointed out earlier. Each printer has its own flip-flop, as you can see. And we are defining those as P1F, P2F, P3F. We're aliasing the printer to D0. We are aliasing the hash console to D3. So the hash console is these guys. Now, all three of these consoles are connected to this guy. All three of them. If I try and turn it on, it might... Yeah, it's not going to let me keep it on. But you'll see... Yeah, it's not going to see anything because they're not requesting anything. But if all three of those were on... then if this printer needed an iron ingot, all three of those consoles will show iron ingot. And the reason I've done it like that is because I haven't got enough pins for additional ones of these. I didn't want to have to keep, every time I use the code, go in and like define multiple of these. Or I didn't want to, you got to connect these to a device. So I just thought, you know what? Let's just save batch name to all of these off, and then if the relevant printer needs something, turn that on, and that is it. So even though if this one was on but this one was off, they are still bringing in the same information. Just makes it a little clearer. You know which printer is working, which printer is missing something, etc, etc. So that is these flip-flops, the printer, the hash consoles. The flip-flop is obviously we are naming that register to flip-flop, and then we are putting P1F into there. Okay, and then we're just aliasing multiple registers just so we can use it throughout our code. Start of the stack, the same thing. Total count again, how many you wanted to. Here on the other code where I had further in the code the sleep, I decided to create a register for it. That way I know it's at the top of the code. It's just easy to change it here. Job done. Code's pretty much the same. The change printer originally was jump to start. That just goes down to change printer. The rest of this is exactly the same. The only difference is it's now using registers instead of using actual devices because it's putting the device IDs into the registers and it's referring to them like that instead. That's just because we can make it dynamic later in the code. All this exactly the same as the other code. Nothing has changed here. All exactly the same. Look, there's the skip. There's the color. Here we are save devicing to the shoot device open, and then we're saving to the flip-flop. Remember, flip-flop is whatever we've set it up as up here. So you can see it's at the start of the code, it's P1F. Nothing special there. Save to the hash console. Again, that is a register that we've got up here. Sorry, not a register. We're aliasing it as the D3 pin. And with that saving the on. So that's why all of those are off, because currently nothing is requesting. Sleep time, like I mentioned to you before, rather than having a number, I've just got a register because I can. Down here, same again. Like if it doesn't need anything, we're setting the setting to 0, setting the color to 2. Same kind of stack pointer check here. Done. But here, instead of jumping to start, we're jumping to change printer. And this is where the magic happens for it to go through each printer. So first, we check whether the flip-flop is the same as P1F. So when the code first starts, we obviously have P1F defined, and then we move flip-flop to P1F. So if we're running the code through the first time, it gets to here, and it's going to go, oh, flip-flop is P1F. Okay, I'm gonna go and activate printer 2. Go into printer 2. We re-alias printer to D1. We move flip-flop to P2F, so we move to the second printer. We alias the hash console again to the next pin. And we save to all of the consoles, so all 3 of those, off. We're going to turn them all off. And then we jump to start. So we're up here, we jump to start. If flip-flop wasn't P1 off, so let's say we've just done printer 3, it would check here, is flip-flop printer 2? No, it isn't. Let's continue down. Okay, well, if we're at printer 3, we want to loop back to printer 1. So again, it just aliases the printer to D0, moves that to P1F, there's your hash console, and there's your batch name. And that is pretty much it. Okay? It isn't... It probably took me longer, and the fact that I wanted to just do it on a single housing made it a lot more complicated than it needed to be. But if we just show it you it working, if I open up all these printers, okay, you'll notice that nothing's really happening. All the stackers were set to 500, so all my ingots are in like large quantities, not in 50s. If I want to, if I wanted to put an ingot in, what I would do is I would turn the printer off. By turning the printer off, it would allow me to put these back in. Now, obviously, my other housing's taking over, so it's kind of requesting ingots that it needs to do. But if I didn't have that chip in, I could just put these in without it ejecting anything, and yeah, that would be job done. But if I close all of these, you can see that it will cycle through the printers, and it will just start providing the ingots that it's after. You can see there, it's moving to this printer. It's going, oh, I'm going to give you some silicon. It's going to move to this printer. And it's going to give it, what are you going to give it? It's going to give it some copper. Now, it is a bit sporadic, to say the least. It will go through and cycle through each printer, as you can see. So the autolathe it's waiting for silicon. So I'll be honest, this was an accident. As you can see, it's working. I need to polish it up a little bit, but no printer is getting more than what it requires. So you can see here, look, it hasn't got 100 silicon. It's only got 50 silicon. It won't now provide any more iron to it. It's going this one, it wants some gold, give it some gold. It'll probably cycle over to the autolathe now. There you go. So it knows the autolathe needs silicon. Now it's going to say that this one needs copper. Any second. There we go. There's the copper. And then this one is going to want iron. But you can see that that's working. Again, sporadic. I need to sort it out. It's just because of how I've got the branching working. It's kind of getting to a point in the code and then going, oh, yeah, the printer needs this one, regardless of what I've already checked. I think I probably need to slow the code down. The code only has, I want to say, a single yield. Got one yield there. Yeah, so we have one yield, and then we have a sleep for however amount we do. That's it. Because the yield, obviously, it's half a tick. It's about half a second. It just takes too long. Whereas this speed is perfectly fine. It just means that the ingots get fed to the printers in a bit of a weird order. This also means that if this printer needs gold and copper, and it tries to provide gold first, and I haven't got any gold, it will be stuck. It won't try and request the copper. It will just stop because it's looking for gold, and it will continue to request gold. It's one of the downsides of having all 3 printers on a single chip. But to be honest, if I ain't got no gold, I'm gonna go get some gold. And I would say that this setup is probably mid to late game, so it's unlikely you're going to be out of ingots. My aim would be for me to set this up. I would have a couple of deep drills. I would have the centrifuges powered up. I would have my silos getting filled left, right, and centre with all the ingots. But it's not hard. Go out and do some mining. Come back in here. You've got the individual chute. I could just feed the gold in if I wanted to. And job done. I'm just going to reset my stackers because they don't need to be on 500. And there you go. All reset. All good. You've got some stuff in you. Just reset you as well. Job done. There's no master reset switch. There's nothing I need to worry too much about. If it gets to a point where I'm run out of an ingot, it will tell me what ingot I need. Go out and get it. Fill it into the system. The code will carry on. It just works. And yeah, it might not be the most elegant setup, but I'm pretty chuffed with myself that I've managed to get this working on the amount of data we have available to us using 6 pins. Again, if I could load from the reagents, if I could load the specific reagent types, I wouldn't need to use these pins. That's the only reason I've got this. And then here, I use these pins here because it was just easier to turn on a specific device. Again, if I wanted to, I could have got the reference ID from them just by getting my tablet and getting the ID, but it already has a lot of setup required. Every time I want to use the code, if on a new world, I would have to define that LED. Obviously, those two can stay. That's fine. I need that LED. There's a bit of setup involved, but once it's up and running, job done. I never have to really worry about keeping my printer stocked. So probably a pretty quick kind of run through. I'm not really going to call this a tutorial. It's more of just like a showcase, show off, I guess. Granted, I'm sure people are going to say, "Oh no, you've done that. You've over-engineered that. You could be so much simpler." You know what? I overthink things, but at the end of the day, I got it working, and I'm pretty goddamn chuffed with it. So, if anyone is interested in the code, let me know. Join the Discord. Pop a message in the comment. Give me your Discord name or whatever, and we can get it shared over with you. Or I could put it on the workshop if anyone asks. If no one asks, I'll keep it all to myself. And yeah, I will be more than happy to use this in my future playthroughs. That was it. Pretty different video. Just thought I'd show you what I've been doing in my spare time. And yeah, until next time, take care, and I will see you then. Bye.